What happens when you walk by someone who is sick? When you are passing by in the hallway, sitting in class, or even in a crowd of thousands? Over 16,000 people attended Thon this year in the Bryce Jordan Center. But what does it mean for all those people if just one person is sick?
Every interaction matters. Every person you pass, every crowd you enter. One sick person may seem harmless, but in a large space with lots of movement, even brief contact can spread illness further than you may realize.
Our project is called TrackingSick. The goal of our project is to model the spread of sickness in crowded environments. But before we could model sickness, we first had to model people. But people do not move like that. We needed movement that looked realistic. People do not walk in perfect straight lines. They stop, wander, avoid obstacles, change direction, and move differently depending on the space around them. See? If our movement was unrealistic, then how our sickness spreads would be unrealistic too.
We split into two teams, the coding team and the simulation team. The coding team used Python to create seamless movement that looks like real people. We developed wandering behavior, collision avoidance, obstacle detection, and logic to keep people from overlapping or walking through walls. We tested our code in simpler rooms first, then we added obstacles and even tested enemies. Each new iteration made the movement more natural.
The simulation team focused on making 3D models and tuning the code so 3D people can move fluidly in the realistic visual models. As the coding team finished each iteration, we created a model in Blender and adapted the code to work in our model. When we were ready, we then used SOLIDWORKS to model the Bryce Jordan Center and Blender to adapt the movement code into a full crowd simulation. We now had a 2-scale version of the Bryce Jordan Center capable of simulating thousands of moving people. Our crowd can wander around concessions, move through hallways, avoid walls, and eventually enter the seating area just like they would at a real event.
Finally, our team implemented the spread of sickness, and our model is ready to answer our question. What happens if just one person is sick in a crowd? In our simulation, healthy people are shown in green, exposed people are shown in blue, and sick people are shown in red. Let's start in one of our smaller rooms. Here is just one sick person in a crowd of 50 people. Now, let's try in the Bryce Jordan Center with 1,000 people. That one person puts countless of others at risk. As people move, the sickness spreads from person to person. Even people who never directly interact with the original sick person can still become exposed through the chain of contact.
We can also look at the data behind the simulation. This graph shows just how quickly sickness spreads from only one infected person. It also highlights how the number of infected individuals increases rapidly over time, especially as more people come into close contact with each other.
Our model can be used to help event organizers, hospitals, schools, stadiums, and other public spaces better prepare for outbreaks and reduce the spread of illness. It could also be expanded in the future to model different sicknesses, different transmission rates, mask usage, social distancing, or even changes in the room layout.
For you individually, this means that small actions matter. One person staying home when they are sick can make a much bigger difference than you realize. All it takes is one sick person to leave thousands exposed and sick.